Today's lesson is on solving compound inequalities. Our question of the day is, how do we solve and graph compound inequalities that contain the word or? So to refresh our memory on what a compound inequality is, it's when two inequalities are considered together. The inequalities can be connected using the words and or. So if we see in the instance here, we talked about compound inequalities that use the word and already, and we know that they can be rewritten like this, where we say that as 52 is less than or equal to h, which is less than or equal to 72. And both statements here need to be true in order to satisfy the inequality. H has to be both greater than or equal to 52 and less than 72. In inequalities that contain the word or, only one of the statements needs to be true to satisfy the inequality. So x either has to be greater than or equal to 49, or it has to be less than or equal to 30. So when we want to find, or when we have a compound inequality containing the word or, we say that their graph is called the union. So in order to find the union, what we do is we graph each inequality separately, and then we think about their graph separately, and then we put them on the same number line. So notice that in this case, when the inequalities are connected by the word or, the shading of the number line does not overlap. In a union, the shading will not overlap. That only happens in the intersection. So here we have example 1, which you'll follow along on your notes. So whenever you see two inequalities or a compound inequality connected by the word or, you're basically going to treat them as two separate entities. Just forget one, solve the other. So in negative 2m plus 7 is less than or equal to 13, we're just going to subtract the 7. And we have negative 2m is less than or equal to 6. We divide by a negative 2, but remember when we divide by a negative 2, we suddenly switch the inequality symbol. So our first inequality is m is greater than or equal to negative 3. The variable is on the left-hand side, which is exactly where we need it to be. So then we take a look at the second part of this inequality, and let's subtract 12 from both sides. So we have 5m is greater than 25. We divide by 5 on both sides. We don't have to flip the inequality symbol because we didn't divide by a negative, and here is the other inequality. So now what we're going to do is graph each individually. So first I'm going to graph m is greater than or equal to negative 3, and since there is the greater than or equal to part of that inequality, I'm going to shade in the circle above negative 3. And if it is greater than, I'm going to shade to the right. Okay, so I finished with that particular inequality. And now we're going to graph m is greater than 5. So there is no equal to symbol here. So I leave the circle open, and I also shade to the right. Now, it is okay for the inequalities to overlap if they're both going to the same direction, but it is not okay if they are going in opposite directions. So in this case, this is what our graph would look like. Here is example 2. In this example, you're going to attempt on your own. So you're going to pause the video, attempt it, and then watch me do the answer out. So pause the video. All right, so remember we treat them as a separate entity when you see the word or. So when we have a plus 1 is less than 4, I'm going to subtract the 1 from both sides. And I have a is less than 3. And then I'm going to do the same thing to the other side. A minus 1, is greater than or equal to 3. This time I'm going to add 1 to both sides. And I have a is greater than or equal to 4. So let's graph a is less than 3. I have an open circle above the 3, and I'm going to shade to the left. Okay, and then for a is greater than or equal to 4, I'm going to color in the circle above the 4, and since it's greater than, I'm going to shade to the right. And that is our union. Okay. here is the did you get it problem. Please remember to finish this example and come in prepared to see your answers tomorrow. Have a good night.